this video is going to be about the net change theorem. Now, the fundamental theorem of calculus states that if f is continuous on the closed interval and capital F is an antiderivative of f, then the integral is just the antiderivative evaluated at b minus the antiderivative evaluated at a. But because capital F prime of x is lowercase f of x, you can rewrite this and turn this into the integral from a to b of f prime of x dx equals the exact same thing. Okay? Now in this case, the f of b minus f of a represents the net change of f of x on that interval. Now, if f prime of x is the rate of change of a quantity, remember, we're talking rate of change, derivative, right? So if we've got a rate of change, then the definite integral of f prime from a to b gives the total change or net change of f on that interval. Okay? So if I'm given a problem where I've got a rate of change and I need to find the total change, I just integrate that rate of change over that interval. For example, a chemical flows into a storage tank at a rate of 180 plus 3t liters per minute. Man, that sounds like a rate of change, right? That sounds like a derivative, where t is the time in minutes and time is between 0 and 60. Find the amount of the chemical that flows into the tank during the first 20 minutes. So I need to know the net change over 20 minutes. All right, so I know the first 20 minutes is from 0 to 20 minutes. I'm evaluating 180 plus 3t dt. Okay? So, we are talking about liters per minute, so our answer should be in liters. And we will just go ahead and integrate that. So, 180 becomes 180t plus 3t squared divided by 2, evaluated from 0 to 20. So, we're going to plug in the 20. So we get 180 times 20. I'll use my calculator to make sure I don't make a mistake. You get 3,600 plus 20 squared times 3 divided by 2 plus 600. All right, that's evaluated at 20 minus 0 plus 0. So we get 3,600 plus 600. We get 4,200 liters. So that's the net change. Now another way to illustrate the net change theorem is to examine the velocity of a particle moving along a straight line, because we know that velocity is the first derivative of position, right? So if we have a velocity function, then I know that's just the difference in its position at the beginning or the difference in its position at the end minus the difference in its position at the beginning. This represents what's called displacement, okay? So, think about this. We know the velocity. If we integrate it, we'll get the antiderivative, which would take us back to the position, right? So we're talking about the difference in how far it went, basically, or displacement. Now, when calculating the total distance traveled by a particle, you have to consider the intervals where the velocity is less than 0 and the intervals where the velocity is greater than 0. Now, when the velocity is less than 0, the particle is moving to the left. When it's greater than 0, the particle is moving to the right. Now, this is total distance, right? If we're just talking about displacement, we're just talking about how far did it go to the right or to the left exactly, right? Where did it wind up? Not how far did it travel total. Now, to calculate the total distance traveled, you have to integrate the absolute value of the velocity. So that makes it a little more challenging, right? So, here's what it's going to look like. If you've got some function here, and we're going to evaluate, if we wanted just the displacement, we're going to take the a minus the a plus the a, right? Because this is a high, we have to subtract that off and then add that. And that'll tell us how the total basically that we have, the displacement. However, if we want to know how far it traveled, it went this far, then it went this far, then it was this far. We have to add all these together, right? So it's really important that we recognize the difference in these two things. Now, here's a problem. So the velocity of a particle moving along a line is vt equals t cubed minus 10t squared plus 29t minus 20. T is in seconds. We want to find first the displacement, then the total distance traveled. So, how do we do that? All right, we're going to look at displacement. We know we just integrate. So we integrate t cubed minus 10t squared plus 29t minus 20 from 1 to 5. So t cubed becomes t to the 4th over 4 minus 10t cubed over 3 plus 29t squared over 2 minus 20t. And we're going to evaluate that from 1 to 5. So if we plug 5 in, you get 5 to the 4th over 4 minus 10 times 5 cubed over 3 plus 29 times 25 over 2, right? 5 squared minus 20 times 5 gives us 25 over 12. And then we're going to plug in the 1. So minus 1/4 minus 10/3 plus 29 halves minus 20. So you get 1/4 minus 10/3 plus 29 halves minus 20. You get 25/12 minus negative 103/12, which is 128/12, which is 32/5. Okay? So it's gone 32/5. Now, that's just the displacement. How do we figure out total distance traveled? Well, to do this, we're going to have to actually look at what the graph looks like. Now, we've got t cubed minus 10t squared plus 29t minus 20. Now, I need to know where it crosses the axis. I need to know if it goes, what is it doing? Now, I know it's got at least 3. No, it has exactly 3 x-intercepts. So we need to find those. So we're going to jump back to our days of pre-calculus and try to figure out what our zeros are. So I'm going to use the rational roots theorem, which tells us that all of our rational roots have to be factors of this divided by factors of this 1. So basically factors of 20. So I'm looking at plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 20. So I'm going to do synthetic division. 1, negative 10, 29, negative 20. I'm going to start with 1. Bring down the 1, 1, negative 9, negative 9, 20, 20, 0. Hey, it worked. So that means we wind up with t squared minus 9t plus 20 equals 0, which factors as t minus 4, t minus 5, which means I have t equals 4 and t equals 5. So I have 1, 4, and 5. Well, 1 and 5 are 2 of my endpoints, right, for my interval. So that means 4 is the only one I have to worry about. So I'm going to have to integrate from 1 to 4, t cubed minus 10t squared plus 29t minus 20. And I'm going to have to also integrate from 4 to 5 of t cubed minus 10t squared plus 29t minus 20. And these are all dt, right? Now, we've already done the integration. It's over here. So this is actually what we're going to be using. Well, not that high. We're just going to be using this part. So I'm going to rewrite that. T to the 4th over 4 minus 10/3 t cubed plus 29 halves t squared minus 20t. And I'm going to evaluate that from 1 to 4. So when I evaluate that from 1 to 4, let's go 4 to the 4th over 4 minus 10/3 times 4 cubed plus 29/2 times 4 squared minus 20 times 4 gives me 8/3. All right. So now when I do this evaluated at 4 and 5, I just evaluated at 4. I have to subtract the evaluated at 1, which is 1/4 minus 10/3 plus 29/2 minus 20, which is negative 103 over 12. So 8/3 plus 103 over 12 gives us 45 over 4. So now we have to do the exact same thing, but evaluate it from 4 to 5. So I'm going to do the 5. 5 to the 4th divided by 4 minus 10/3 times 5 cubed plus 29/2 times 5 squared minus 20 times 5 gives us 25 twelfths minus, we've got 8/3. We wind up with 25 twelfths minus 8/3, which is negative 7/12. So we can see that this is a negative number, which means we were going down. So we're going to say 45/4, take the absolute value of that, 7/12. 45/4 plus 7/12 equals 71 over 6. So remember, when we're doing total distance traveled, we're going to take each piece of the integral, we're going to evaluate the absolute value and add all of the absolute values together. So if you have any questions about this, just shoot me a reminder or ask a question in class. Alright, so this is a little addendum. I made a mistake. I want to go back and correct real quick. Let's see. Maybe some of you caught it right here. This does not simplify to that. That should be 32 over 3. Yes, I just looked at my calculator wrong. Hopefully y'all caught that. I'm going to cry about it. So, if you have any questions, let me know.